Hi and Assalamualaikum. My name is Amira Yasmin binti Muhammad Amir, and I will be explaining for the greedy algorithm for this Rrop project. So what is greedy algorithm? It is a simple optimization technique that selects the best option available at each step, and it does not reconsider previous choice. These local decisions lead to a globally optimal solution. It is simple, fast, and works well for problems that doesn't require exhaustive searching. However, it does not always guarantee the best overall solution because it only looks for immediate benefits, not for long-term consequences. So for this Rrop, we use this approach to find the quickest route for a relief vessel to visit all ports and centers. So this is the source code for greedy algorithm. This is the distance matrix. It stores the distance between each pair of locations. For example, the distance from port A to port B is 15 nautical miles. Next, we create a visited array to keep track of which locations have already been visited. So we start at port A, which is location 0, so we mark it as visited. In this part, the algorithm loops through all locations and finds the nearest one that has not been visited yet. It keeps track to the minimum distance and updates the path and total distance each time a new location is selected. After all locations have been visited, we add the distance from the last location back to the starting point, which is port A, to complete the cycle. Here is the output. It returns the complete route and the total distance traveled, which is 88 nautical miles. And that is all for greedy algorithm. Thank you.
Hello, Assalamualaikum. My name is Patricia Balkis binti Rozi. I will explain dynamic programming and how it is used in the relief route optimization problem. Okay, let's start with what is dynamic programming. Dynamic programming, or DP, is a method used to solve a complex problem by breaking them into a smaller sub-problem. Instead of repeating the same calculation many times, DP store results in a table and reuse them. This makes the algorithm faster and more efficient. Why do we use DP for the Rrop? In the narrative relief operation, we need to find the best route to deliver supplies to multiple ports. Dynamic programming helps calculate the shortest possible route by trying different combinations and keeping only the best result. This gives a more accurate answer than using a greedy or a simple backtracking. Okay, let's continue to how the implementation works. In my project, I use the help cup DP method in Java. The distance between ports is stored in a matrix. A recursive function computes root cause, and every result is saved into a memo table, so it is not recalculated again. This saves time and reduces processing costs. In the end, DP returns the minimal total distance and also the best visiting sequence. So here, this is my output for my program code.
Hi everyone, my name is Nur Aya Zakira and I am from section 3. So for our project, I will talk about backtracking method. Backtracking is basically trying all the possible paths and picking the best one. If a path doesn't work, it will go back and try another. So this is why it's called backtracking. We also usually use recursion to do this. So how does this relate to the relief route optimization problem? It's because our ships needs to visit every port and relief centers to find the shortest route. So the goal is very simple. It needs to visit every location once and then return to the starting port and make the total distance as short as possible. Backtracking always finds the shortest route, but it can be slow if there are many locations. So now looking at the Java code, the recursive function, which is TSP backtracking, explores all possible routes. The visited array keeps track of which ports has been visited. If a route gets too long, it backtracks and tries another sequence until all ports are visited. Finally, the result shows the shortest route: port A, port B, relief center D to relief center C and back to the port A, with a total distance 88 nautical miles. This proves that backtracking can find the best route for our relief vessels. That's all for backtracking.
Hi, my name is Rrop. My part in this project is divide and conquer for the algorithm design technique. Divide and conquer is a problem-solving method that breaks a big problem into smaller subproblems. Each subproblem is solved independently, and the results are then combined to form the final solution. There are three main steps. First, divide. We split the main problem into smaller similar parts. Second, conquer. We solve each smaller problem usually by using recursion. Third is combine. We merge the solution to get the complete answer. In our project, divide and conquer is applied to the relief route optimization problem. The program starts at port A, making it as visited. It then recursively explores every unvisited location. For each option, it temporarily makes the location as visited and calculates in total distance if that path is chosen. The algorithm keeps track of the path with shortest distance found so far. Once all locations are visited, it adds the distance back to port A to complete the route. The recursive function uses a string builder to record the current path. After checking all possible options from a location, the best path is stored at return. The function backtracks by unmarking locations so other routes can be explored. This continues until the shorter route covering all locations is identified. Overall, the implementation ensures that all subproblems are solved efficiently and the final solution is accurate. By breaking the problem into smaller parts, we avoid handling the full complexity of the route at once. This makes divide and conquer ideal for structured, step-by-step optimization in maritime relief operations. Thank you.
Assalamualaikum, my name is Julina Diana and today I will be presenting about insertion sort, binary search, min heap and also split tree. I will begin with explaining the concept of each of it. Firstly, insertion sort is a simple way to arrange numbers in order. It works by taking one number at a time and putting it in the right place among the numbers that are already sorted. This continues until all numbers are in order. Next, binary search is a quick way to find a number in a sorted list. It checks the middle number first, then decides whether to look on the left or right side. It keeps dividing the list until it finds the number or no, it's not there. Thirdly, min heap is a tree structure where the smallest number is always on top. When you add or remove numbers, the tree automatically arranges itself so the smallest one stays at the top. This makes it easy to get the smallest value quickly. Lastly, split tree is a tree that moves the search or add number to the top each time you use it. This helps make the tree faster for items that are used often because they stay closer to the top. Here is the insertion sort part of my program. Insertion sort is a simple way to arrange numbers in order. It goes through the list one element at each time and place each number in the correct position among the ones that are already sorted. In the code, the key represents the current number being sorted, and the while loop shifts the larger number to the right. This continues until the whole array is sorted. It's an easy to understand sorting method, but it works best for small lists. Binary search is a fast way to find a number in a sorted list. The program starts by checking the middle element. If the middle value is the number we want, it stops. If not, it checks whether the number is smaller or larger and then continues the search in only one half of the list. This process repeats until the number is found or the list is fully checked. It's much faster than checking one by one because it keeps cutting the list in half. Next is the min heap section. A min heap is a special structure where the smallest number is always on top. In the code, I used a priority queue to create this min heap. When a number is inserted, the heap automatically arranges itself so that the smallest value stays at the top. When we use the extract min function, it removes and shows the smallest number. This is useful when we always need to get the smallest item quickly. The last part is the split tree. A split tree is a self-adjusting tree, the most recently used data to the top. Each node has a value and links to other nodes on the left and right. When we search or insert a number, the tree rearranges itself so that the used node moves to the top. This helps make future searches for that number faster. In simple terms, the split tree keeps the most important or frequently used data easy to access. The driver method tests all parts of the program. It sorts a sample array, searches for a number, extracts the smallest value from the min heap, and searches in the split tree. Its purpose is to show that all functions work correctly. And lastly, this is the output from my program. Thank you.